functioning of internal structure. Plants also internally they do so many functions like growth, respiration, transpiration, and photosynthesis, absorption. So all these are physiological processes carried out by the plants. And today we are going to see absorption. One of the physiological processes takes place in plants. Okay. Then why do the plants should absorb water? Okay. First one, need. Can you see this? I have written it on the board. Can you see? Okay. Why the water is needed? Why the plants need water? For photosynthesis, they need water. And for the protoplasm is the physical basis of life. So protoplasm contains water. The cell sap, vacuole contains water. And to keep the cell rigid, they need water. So for all these processes, water is necessary. Okay, how the water enters into the plants? Through absorption. So roots absorb water. Roots absorb water. From the lower classes we have been studying, roots absorb water. And how this absorption? The water is not telling, may I come in? Yes, come in. Not like that. Automatically the water enters into the cell. The roots are not absorbing, sucking water like straw. Not like that. It is going inside. The water is entering inside the plant cell without asking any permission. Okay. So how this absorption takes place? It takes place in three processes: imbibition, diffusion, and osmosis. Imbibition. Imbibition is entry of water into the substance by surface attraction. Surface attraction. See, yes, in this one example, we can see the raisins. The raisins are of this size. Okay, can you see the size of the raisins? Okay, so this size raisin, when they are soaked in water overnight, became like this. Okay, so this is imbibition. The raisin imbibe water. Okay, this is one example for imbibition. The next comes the diffusion. Diffusion, the distribution of molecules, solute molecules, into the liquid, into the gaseous state. At any state it takes place. Okay, for this imbibition, one condition, when the water should enter through imbibition means that substance should not dissolve in water. Okay, but diffusion is not, that's not required, that condition. Okay, now diffusion, I can demonstrate diffusion in one particular simple experiment. In school, we will be doing another experiment with potassium permanganate. And now I am going to do, I don't get potassium permanganate, I am going to do with kesari powder. Okay, it is food color, and the water I have. Okay, see, I am going to put this food color. See, the food color diffuse. Can you see this? It diffuses into the water molecules. Okay, this is an example for diffusion. So diffusion does not require any conditions. Okay, the next comes the osmosis. Osmosis is a process which requires conditions. What are the conditions? First, the concentration should be different. Okay, concentration of what? Concentration of solvent. Where it should differ? It should differ in the water, concentration of water differ in two solutions. Suppose if we take sugar solution and cell sap. In this funnel experiment, we will be doing it at home, doing it in the school for practicals. So thistle funnel experiment, we don't have thistle funnel, and so we will be doing it in the practicals. Two separate solutions of different concentrations are separated by a semi-permeable membrane. Okay, semi-permeable membrane. Permeable, it allows all the substance. And partially permeable or semi-permeable, it allows only water and certain substance to pass through. So the cell membrane is semi-permeable. Okay, cell membrane is semi-permeable. Now, what happens if the two solutions are separated by a semi-permeable membrane? The water molecules, solvent molecules, very important. The solvent molecules, from its higher concentration, it enters into the lower concentration. Okay? Suppose if you take the protoplasm or cell sap, it contains water and some dissolved substance. Okay? And the water in between the soil particles, that is only water. Okay? So soil particles, only water. Soil water. Here the water is water plus some substance. And here only water. So where the water content will be more, here the water content is more. So the water molecules enters from its higher concentration. Okay? High concentration to the lower concentration. So it enters into the cell to osmosis. So osmosis is a process in which when two solutions of different concentration are separated by a semi-permeable membrane, the solvent molecules from its higher concentration enter into the lower concentration. Okay? And how long it takes place? Till the concentration of both solutions becomes equal. Concentration of what? Solvent molecules. Till the concentration of solvent molecules become equal, it will be transferred. Okay? It will be passed on, carry out this process. So that is osmosis. So plants use all these three for osmosis. Okay? So I hope all can see. Okay. Now, the next one, the osmosis is of two types, endosmosis and exosmosis. And don't think that osmosis, the water will enter only into the plant. Water will come out of the plant. Okay? So, what is endosmosis? When the water comes into the cell, it is endosmosis. If the water comes out of the cell, it is exosmosis. Okay? Endosmosis and exosmosis. So these are the two types of osmosis. Okay, when the water endosmosis takes place, osmosis, the water enter into the cell more and more. What happens? The cell becomes turgid. That is turgidity. The cell becomes turgid. More and more water enters into the cell. The cell will bulge. Okay? And if the water comes out, exosmosis, if the water comes out of the cell, the cell will become flaccid. It attains flaccidity. It attains flaccidity. Okay? So, here, to show this turgidity and flaccidity, I have two leaves. This leaf, I put it in the water overnight. See how stiff the leaf is. Okay? The same plant, I taken another leaf and I soaked it. I kept it in the salt water. Can you see both the leaves? Can you see both the leaves? Okay? This is normal water and this one is salt water. Okay? So this is flaccid, this is turgid. Turgidity. When the water enters into the cell bulge and become turgid. Because of that only it is stiff. Okay? And the exosmosis, the water, salt water, the water content is less in salt water. So water from the cell sap comes out, so that these leaf, because of that only, this leaf becomes flaccid. So this is flaccidity, this is turgidity. Okay. The next is osmotic pressure, turgor pressure, wall pressure. So not only these things are helping absorption, some more process, osmotic pressure. Osmosis, already we have seen what is osmosis. So due to osmosis, this water enter into the, and the osmotic pressure depend upon the water content. Okay, that is osmotic pressure. How much water content is there, water molecules are there, that the osmotic pressure will be more there. Solvent molecules, not only the water molecules, solvent molecules. The next one is turgor pressure. Due to the entry of the water inside the cell content become bulge and it press on the wall of the cell wall. So the pressure exerted by the content of the cell on the wall is called turgor pressure. Turgor pressure. Now wall pressure. Wall pressure, the cell wall is exerting the pressure on the content. If more and more water is entered, so the cell wall is showing pressure on the content. So the pressure shown by the cell wall on the cell content is called wall pressure. The pressure shown by the content of the cell on the cell wall is called turgor pressure. All these things help in absorption. Okay, so this now we are going to see how the water is entered into the cell. These are the soil particles and root hair, vacuole. Now this vacuole contains cell sap. Root hair, of course, it's a plant extension of the epidermal cell. This is the cortex, endodermis, xylem, phloem. Okay, this is the vascular bundle. In anatomy you will study. And here the water is there in between the soil particles, capillary water. So the root hair enters into the root particles, soil particles, and the water comes in contact with the soil water. Now what happens? The cell wall imbibes the soil water. Okay. Then next to the cell wall, what is there? It diffuses into the space between the cell wall and the cell membrane. Okay. Now the cell membrane is semi-permeable. So through the plasma membrane, cell membrane, the water enters into the cell. So from here, this process, due to this process, the water is entering into the root hair. Now the root hair and adjacent cell, if you compare, the root hair cell contains more water, the adjacent cell contains less water. So higher concentration to the lower concentration to this cell. It enters into this cell, same process. From this cell to this cell, from this cell to this cell, from this cell to this cell, all the cortical cells. Okay, and the pressure exerted in the cortical cell is called root pressure. The pressure exerted in the root, cortex of the root is called root pressure. I tell you how the root pressure is going to help the plant. Okay, so this root, after reaching this cortical cell, the endodermis. If you take this endodermis, endodermis cells are covered by Casparian stripes. But the endodermal cells which are near to the xylem vessels will not cover with the Casparian stripes. So those cells are called as passage cells. And through the passage cells, it enters into the passage endodermal cells, enters into the xylem. This is a metaxylem and protoxylem. Okay, from one xylem to the other xylem, how it enters? The xylem vessels, if you see the xylem vessels, they have the thickenings on the wall. So they are connected, the xylem vessels are connected with each other through this thickenings. Thickening in the sense, I have drawn the circle here and these places here, it is thin. Okay, so through that the xylem vessel. Okay, so now this how the xylem vessels are filled with water now, and this water should reach the leaves. Okay, for that it needs the root pressure and transpiration pull. Okay, now so far we have been discussing about water. Along with water, some minerals also will be entering into the plant. So roots absorb water and minerals from the soil. So these minerals transport as ions. So this transport of minerals takes place into process active transport and passive transport. If the transport of these minerals takes place without using any energy, automatically it is called passive transport. If it takes place by utilizing energy, it is called active transport. Okay, so passive transport, active transport, with the help of it, the ions also mix with the water. So how the water and the mineral ions enter into the xylem, we have seen. How the xylem is sending the water to the leaves. See, due to root pressure. Root pressure, already I told you, the pressure exerted by the cortical cells is called root pressure. This root pressure is keep on sending the water. This water, the xylem vessels are, because of the transport of water, the xylem vessels are filled with water. Okay? And transpiration, that is not enough to send. If it is a small plant,
வீடியோ எடுக்க முடியாது ஆஃப் பண்ணிட்டா ஆமா வருது மெசேஜ் இதுக்கு மேல வீடியோ எடுக்க முடியாதுல கிளியர் பண்ணிரணும்
ஆஃப் பண்ணிட்டு மறுபடியும் கண்டினியூ பண்ணுங்க this transpiration for this root pressure is not enough for the trees you can imagine the height of the trees the topmost leaf also should get the water absorbed water from the xylem so this water is pushed to the topmost leaf pushed to upper due to transpiration pull. Okay, transpiration, what is transpiration? Removal of excess water. Next class we are going to, next lesson will be transpiration only. So this transpiration is removal of excess water. The leaves utilize water for their photosynthesis and the remaining water has to be sent out. Why it has to be sent out? We will see in the next lesson. This transpiration is removal of excess water. From the xylem the water is transpirated. Okay, sent out water vapors. So the xylem vessels are empty. So that is filled with once the xylem vessels are empty, the water enters to the xylem vessels. Okay, so due to this only, it is pushed upward. Okay, so these two processes, root pressure and the transpiration pull. The movement of the water in the xylem, the movement of the water in the upward movement of the water in the xylem is called ascent of sap. Okay, so we will be seeing some experiment to prove this ascent of sap, osmosis. Okay, then how this absorption takes place. All these experiments we are going to do in practicals. Okay, so we will be doing this practicals. There is osmosis and diffusion we will do in practicals. Osmosis, diffusion, then ascent of sap, thistle funnel experiment. Thistle funnel experiment, the thistle funnel will be like this and we have to take the thistle funnel tie it with a sheet blader or this cellophane paper. Fill the thistle funnel with sugar solution. Dip the funnel in a beaker which contains water. Now what happens? This cellophane paper acts as a semi-permeable membrane. Here only water molecules, here water molecules and the sugar molecules. So where the concentration will be more, concentration of water molecules, it will be more here only. So from the higher concentration, the water molecules enter into this thistle funnel through the cellophane paper. It acts as a semi-permeable membrane. And what we have to do after keeping this set up, we have to mark this initial level of the sugar solution in the stem of the thistle funnel. Now after some time you can see this slowly it will increase the level of the solution, sugar solution. So why it is stopped? That condition, it is the concentration of the water in this inside the thistle funnel and in the beaker both become same, so it stopped. Okay, so we can prove that osmosis takes place, the process of osmosis with this thistle funnel experiment. And to make the thistle funnel that we will do in the stand, we will fix it with a stand. Okay, so all these things. Okay, now the next one is the next experiment. One more thing I want to say is plasmolysis and deplasmolysis. Plasmolysis and deplasmolysis. I said flaccid, no? The leaf is flaccid and turgid. Okay? Why this leaf has become flaccid? Because I soak it in the salt solution. I soak it in the salt solution. When we discuss this plasmolysis and deplasmolysis, we must go through the tonicity of the solutions. Take types of solutions: isotonic, hypertonic and hypertonic. Isotonic solutions, the water molecules are equal, the solvent molecules concentration is equal in outside in the solution as well as in the cell content. Hypertonic, the solvent molecules, the concentration will be less than the cell content. Hypertonic, the concentration of the solvent is more in the solution compared with the cell content. Okay, so if we keep a cell in the water content, what solution, salt solution, it will become flaccid. Okay, so if you take the cell content, if you observe that flaccid, one of the cell from the flaccid leaf, if you observe it under the microscope, you can see all the protoplasm condensed. That condition is called plasmolysis. Okay, how to bring it out, bring it back to its position, back to its state, that is deplasmolysis. If we keep the same plasmolized cell, if you take the plasmolized cells, if you observe the plasmolized cells under the microscope, it will be like this. And the protoplasm is condensed like this. And this cell is said to be plasmolized condition. Okay, so flaccid cell, plasmolized condition. How to bring it back to its original condition? If you keep the same cell in water, it will get deplasmolysis. It will come back to its original condition. That is called deplasmolysis. Okay, so we have seen here an absorption. Okay, if you say absorption, roots absorb water. If you say like that, the small children will be asked. To prove the process of absorption, we have to conduct an experiment. Take a test tube and fill it with water. Keep a drop of oil on the surface of the water and insert a rooted plant. Keep this setup without disturbing it. The next day, if you take and see, the water level will go down, reduced. So what happened to the water in the test tube? It has been absorbed by the plants. Okay, why we are keeping a drop of oil on the surface of the water? See, the water level is decreased. The water has gone somewhere. It might have gone as evaporated water also. No. So, in order to avoid this evaporation, we are keeping this oil on the surface of the water. Okay. So, where the water, there is no chance for the water to get evaporated, but it is decreased. Then what happened to this water? It might have been absorbed by the roots. So, with this experiment, we can prove that the plant absorbs water by roots. Okay, so we have seen this lesson, absorption why plant need water, what are the process which helps absorption, imbibition, diffusion, osmosis, then types of osmosis, endosmosis, exosmosis, types of solutions on the basis of the tonicity. We can classify the solution on isotonic, hypertonic, hypotonic. Then turgidity, what is turgidity, flaccidity, what is osmotic pressure, turgor pressure, wall pressure, and transport of mineral ions, active transport, passive transport, and conduction of water, the factors that helps the conduction of water, root pressure and transpiration pull. So with this we are finishing this absorption lesson. Okay, we will meet in the next class. Bye.